All right, you guys ready? Class?
Yes.
Thank you very much. So, all right, so we are here. So, exponential functions. There we go, yeah, just review.
Yeah.
I know, you're just waiting for me to say something like life-changing and interesting, but it's really not. Anyway, exponential functions. Let a be a positive real number other than 1. Okay, now serious question. What is 1 squared? 1. What is 1 to the 5th power?
1.
1. Okay, so is there a reason why a has to be a number other than 1?
Yes.
Yeah, because otherwise if it's 1, it's not going to change.
Make it 0.
Anything to the 0 power is 1. Did you know that one?
I sort of did remember that, yeah.
Oh, okay. All right. Anyway, so the domain of this is from negative x to positive x, and the range is from 0 to x. Does that make sense? Probably not, right? But it will make sense when we actually have real problems with it. Compound interest investments and population growth are examples of exponential growth. Exponential growth if a is greater than 1. A is greater than 1. Okay? So that's super important. If it's greater than 1, it's going to be growth. If it is less than 1, okay, let's try this again. Let's see if we're paying attention. Okay, so greater than 1 is going to be growth. Less than 1,
Decline. Decay.
decay. There we go. That's the opposite. I swear I have like a hair stuck right here. I don't know. It's like sometimes I wake up and I have this hair wrapped up in my beard, and it's crazy. I'm like, where the hell did a foot long hair come from?
Isn't that your wife?
Yes, it is, but still, it's but it gets woven in my sleep. It gets woven into my beard, like some type of braid or something like that. I have face cornrows with her leftover hair. Anyway, all right. So F looks like the graph right here. So it is growth. It is going up. It's kind of like the zombie problem. So if a zombie bites you, and for every person that a zombie bites is going to turn into another zombie. So if I am the zombie, okay, I'm going to bite one person, and that person's also going to bite one person, right? And then we're going to keep. So let's say, for instance, just basic zombie math. Okay, I am the zombie. I go bite 3 people, and those 3 people go bite 3 people. Okay, so now at the second tier, so start with 1 person, got 3 zombies, and now those 3 zombies are all going to bite 3 people. And so now that's going to be, so if each does 3, right? It's going to be 9, right? Okay, so now that's at the second, okay, and now those 9 are now also going to bite 3 people.
27.
Okay, and as it's growing up, it's growing exponentially as we do that. So yes, that is zombie math. Now, if it looks like this, okay, this is actually going down here. So if you notice, what is it going down to?
Almost a 0, but
0. It's going down to 0. So what is it called if it's approaching a number but not going to that number? Kiss my what? Asymptote. What? You will remember it now because of that.
Yeah.
So it is an asymptote. It is the MC Hammer of math because
Asymptote.
no, can't touch this.
No.
Wow, come on. Can't touch this. Y'all suck. Finding zeros. A graph for to find zeros right here. We have the function f of x equals 4 raised to x minus 3. So finding zeros on a graph right here, a couple things going to happen. So this point right here is super important. Why is that super important? What value is that? That's my y-intercept. Very good. That's my y-intercept, right? At my y-intercept, what do I know about my x value? My x value is 0. That's why that is important. I know that my x value has to be 0, and that's going to give me my y-intercept, isn't it? So can I plug in 0 and get my y-intercept? Yes, I could plug in 0 for my x, right? And so I could evaluate it there and get my y value, and that would be my y-intercept. What about this other thing over here? This is my what?
X-intercept.
That's my x-intercept. What do I know about the y value at my x-intercept?
0.
It's 0. So in this one, it's not the same evaluate like this. This is my x's, and then my y is going to be 0. So I have to set my function equal to 0 to get that one. Okay, so the difference is that for here, it would be f of 0. And over here, this would be 0 equals two different types of functions. Okay, there were some homework problems that people struggled with on this, on that last one, where it was not an evaluate like this by plugging in the x, it's set it equal to this value. Okay, different types of functions. Okay, rules for exponents. If a is greater than 0 and b is greater than 0, follow hold true for all real numbers for x and y. So, right here, a is my base. This is commonly referred to as the base as it is the number being raised to the power. They have the same base. A and a, same base. If I'm multiplying, I add the exponents. This is going to be key for a lot of the stuff we're doing later on. Okay, same base. Okay, if I divide them, I subtract my exponents. Okay, so right here, I have a to the x raised to the y. I would multiply the x and y. Multiply the x and y. Over here, I have different bases, but same exponent. So different bases, same exponent. So that means I can bring my exponent out here and put those bases together because those bases are still being multiplied. Right over here, and I have a fraction being raised to an exponent. Each item in that fraction has to be raised to that same exponent. And this is going to be super important for some of the stuff when we break down problems later on. Half-life. Exponential functions can also model phenomena that produce a decrease over time, such as happens with radioactive decay. The half-life of radioactive substance is the amount of time it takes for half of the substance to change from its original radioactive state to a non-radioactive state by emitting energy in the form of radiation. Now, one of the things that they actually do this a lot with is carbon dating, to see how old something is. So they take some ancient artifact and they carbon date it because carbon-14, there is a rate of decay where carbon-14, since it is radioactive, all things, all living objects are radioactive. Did you know that? Even you are radioactive.
Yeah.
Okay. Carbon-14 has a measurable, it is an exacting science, where the carbon-14 will turn into carbon-12 over a period of time.
Define what's carbon-12.
Huh?
Like actual carbon gas or like?
It's the element of carbon-12.
Oh, okay.
So yes, so while you are living, you still are producing carbon-14. You still are carbon-14 positive. So from the time of your death is when that no longer occurs, and then it will continuously decay from that point on. Does that make sense?
Okay.
Yeah.
Once I die, it's like.
Yeah, once you die, you are going to turn into carbon-12 over a period of time.
Okay.
Okay, and there is a model for that. exponential growth and decay. So the function y equals k times a to the x, where k is greater than 0, is a model for exponential growth, and a is greater than 1. And a model for the exponential decay is it's going to be less than 1, but greater than 0. Less than 1 and greater than 0. That's important. Okay, less than 1 and greater than 0. Think of it like this. So if I'm going to use this analogy here. I'm going to walk from the front of the room to the back of the room. But my let's say my A value for this is going to be 1/2. So if every time I do this, I only walk half the distance. So in the first day, I'm going to walk half the distance. So I'm walking half the distance from here to the back of the room. The second day, I walk half the distance. So I am now 3/4 of the way. The third day, I walk half the distance. Fourth day, half the distance. Am I ever going to really get to the wall?
No.
No, because it's always half the distance of in between here and there. I'm never going to go all the way because it's always going to be half the distance. It's slowly approaching that number. Oh, Veracruz. Sorry. That's it. And this. Read that for me. I can't read it. No, my dyslexia. I have problems with, don't you even. You're trying to read the whole thing. Sorry.
Just ask Veracruz.
I was trying to. Don't judge me. I feel judged now. Don't look at me in that tone of voice. Anyway, all right. I will never fully get there because the half-life, I'll always be going halfway. Compound interest formulas. An account begins with the principal P, earns the annual interest rate R, compounded n times per year. Then the value of the account in T years is this.
I have not seen that since last year.
Okay, yeah, we'll do it. Anyway. Bunch of different formulas. Number E. Many natural, physical, economic phenomena are best modeled by exponential function whose base is the famous number E.
Why E of all numbers?
Because all the rest were already taken.
Oh, really?
Like tau, pi,
What about Z?
that was zeta.
Oh,
Yeah, different things. Anyway, so E is a number, okay, and it keeps going. It's an irrational, constant number. So this is it to 9 decimal places. You know, pi is a similar number that shows up all the time, which is 3.14 blah 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 blah, right?
Yeah.
E is similar.
2 points.
We can define E to the number that the function right here approaches as x approaches infinity. And so that is going to be a limit function where we eventually, as we keep doing this over and over and over, we get into larger and larger numbers that it is approaching infinity. Now, actually, I'll save that till later. Okay, exponential functions, y equals e to the x and y equals e to the negative x are frequently used as models of exponential growth or decay. Continuously compound interest formula is going to be principal P times e to the r raised to the t is my time. Continuously compound interest. So Bernice deposit $2,500 in account, earning 5.4 interest annual interest. Find the value of the account in 10 years if the interest is compounded daily. Okay, so this is a daily interest. Okay, continuously. Let's go back to the formula. right there. So P is going to be what?
Principal.
Okay, and in that problem, it's going to be how much?
2,500.
2,500. Very good. Now, R, what's going to be R? Five. It's good.
0.054.
Very good. 0.054.
0.
You know why?
Yeah, because it's in the hundred. No, it's,
It's percent.
yeah, it's percent.
Okay, percent, and we always have to have this as a decimal. So it's going to be is my P, my R, 0.054, and T, oh wow, that did not work out. T is 10 years. So if we're going to compound it daily, okay, here it is. This one's for daily. So if it is daily, how many times is that compounded a year?
4.
Try again. If it's daily, how many times does it happen a year? 365.
So it's like every day.
Yeah, daily.
Okay.
Yeah, 365. So we're using this formula on the problem. So my principal in here is 2,500. Principal, and then 1 plus my rate, 0.054 over 365, raised to the 10 years times 365. So my first part of my question is asking me to do it daily. Make sure when you plug it into the calculator, you're using the calculator correctly. Okay. Put your your parentheses, and then your fractions, because fractions are your friends, not food. And I am opening up my calculator. What the hell? Come on now. Okay, I'm gonna get there right about meow. All right. So you start off here in Scratchpad. So second button on the left is gonna be my Scratchpad. So in my Scratchpad, I'm gonna put 2,500 parentheses 1 plus. Now, one of the things that's super neat about this calculator, it's super smart, and you just need to know where everything is. So to enter a fraction, I would go Control Divide. That's a tool for that. Okay, and then that's going to be my 0.054 over 365. Arrow over, close it, caret to raise my exponent. Caret's right here.
Okay.
It's the red button. And then it's going to be 10 times 365. And my answer is
How do I press?
where it says enter.
Oh,
Okay. All right, so I get 4289.85. So there's my daily. My next one is going to be asking for continuously. So continuously is the E one, right? The E.
Yeah, the one with E.
Okay, so it's going to be 2,500 E raised to the
0.054 times 10.
So let's double check my formula. There it is, my rate times time. Did I?
Are you supposed to close it? I thought the rate.
No, it's gonna be. No, it's fine. Because I did it like this one here. It's the same over there.
It's just the same, okay.
Yeah, it's the same. You got me worried there. I was like, oh, did I screw this up? Did I screw this up? And I'm also recording it too, so that's even worse when I record it screwed up. So E is right above the left parentheses. $42.90.02. So which one is better?
In terms of what?
It's money, right?
Oh, yeah,
Do you want more money or less money?
more money.
More money. Do you know what they say about more money?
It was,
More problems.
It's more disgusting.
More money, more problems.
More disgusting.
Anyway, so 42.90.02, which if I'm looking at my calculator, which one is better for me?
Continuous one.
Yeah, the continuous. But it's about the same. So depending on what formula you're using, it's about the same. All right, so let's keep going. Now, you got your review?
Yep.
Okay, and what's after the review?
What's after the quick review is just
And that's it. So we're done with today's lesson. You guys are going to work on this. And for your I-Day assignment is you're going to finish this and upload it on when?
Monday.
Monday. So do you think you could actually get this done today in class?
Yeah.
Yeah. So do you think you're going to have to deal anything on Monday? No, good. So one of the big issues that the school's doing right now is if you do not do your Monday assignment, you have to be marked absent. And if you get to 3 absences, that's the first parent conference.
Oh, wow.
So, all right, make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.